Have you ever wondered what happens when the lights go out? That sudden silence, that immediate plunge into darkness? For a moment, our modern world just stops. No phones, no internet, no TV, no heat, no air conditioning. A stark reminder of how much we rely on a force we can't even see: electricity. But where does it all come from? How do we learn to harness this incredible power that fuels our entire civilization? The answer lies not in a high-tech lab, but in the brilliant mind of one man over 190 years ago, a man who changed the world with a simple spinning disk. Let's travel back to London, 1831. The city is a bustling, chaotic world of horse-drawn carriages, gas lamps, and steam engines. Science is in a golden age, and at the heart of it is the Royal Institution, where a man named Michael Faraday is working tirelessly. Faraday wasn't born into privilege. He was a bookbinder's apprentice with an insatiable curiosity. He read every book he bound, especially those about science. He dreamed of a world beyond the dusty print shop, a world of experiments and discovery. Through sheer determination, he landed a job as a lab assistant to the famous chemist Humphrey Davy, and his journey into the heart of science began. For years, a fascinating puzzle had captivated scientists. A Danish physicist, Hans Christian Ørsted, had discovered that an electric current could create a magnetic field. Think about it. Flowing electricity could make a compass needle twitch and turn. This was a revelation. It proved a deep connection between two seemingly separate forces: electricity and magnetism. This discovery led to the invention of the electromagnet, a powerful tool that could lift heavy objects with the flip of a switch. But Faraday, ever the deep thinker, couldn't shake a question that burned in his mind. If electricity could create magnetism, could it work the other way around? Could magnetism somehow be used to create electricity? This idea, this simple question of symmetry, became his obsession. For 10 long years, he chased this ghost. Wrapped wires around iron rings, he passed magnets through coils, he tried every configuration he could imagine. He was convinced there was a link, a hidden secret waiting to be unlocked. Time and time again, he faced failure. His experiments yielded nothing but frustrating silence. Many would have given up, but Faraday's belief was unshakable. Then came that fateful day, August 29, 1831. Faraday set up a new experiment, one that seemed almost too simple. He took a strong horseshoe magnet, one of the most powerful of its time. Between the poles of this magnet, he placed a copper disc, about the size of a dinner plate. He attached 2 wires to the disc. One wire touched the center axle, and the other rested against the outer edge. These wires then ran to a galvanometer, a sensitive instrument that could detect even the tiniest flow of electric current. With everything in place, he began to turn a crank, causing the copper disc to spin between the magnetic poles. He watched the galvanometer needle, his heart likely pounding with a mix of hope and nervous anticipation. And then, it happened. The needle, which had been perfectly still, began to move. It deflected, indicating a steady, continuous flow of current. He spun the disc faster, and the needle moved further. He spun it the other way, and the needle deflected in the opposite direction. This was it. This was the moment. He had done it. For the first time in human history, mechanical motion had been directly converted into a continuous electric current. It wasn't a spark. It wasn't a static shock. It was a steady, flowing river of electrical energy. This simple device, a spinning copper disc in a magnetic field, was the world's first electric generator. Faraday called it electromagnetic induction. Imagine the sheer awe of that moment. Faraday had proven that a moving magnetic field could induce a current in a conductor. He had found the missing piece of the puzzle. The relationship between electricity and magnetism was a two-way street. This wasn't just a clever lab trick. It was a fundamental law of nature he had uncovered. His detailed notes from that day capture the quiet excitement of his discovery. It's the meticulous way he recorded every detail, ensuring the result was real and repeatable. The news of his discovery spread like wildfire through the scientific community. It was a breakthrough of monumental proportions. But at the time, few could grasp its true potential. The current his little disc produced was tiny, barely enough to make the galvanometer needle twitch. It was a scientific curiosity, not a practical power source. There's a famous, perhaps legendary, story that when Faraday demonstrated his discovery to a politician, the man asked, "But after all, what use is it?" Faraday's reported reply was classic, "Sir, I do not know what use it is, but I'll wager one day you'll be able to tax it." And how right he was. Faraday's discovery laid the foundation for virtually all the technology that powers our world today. His principle of electromagnetic induction is the beating heart inside every power plant on Earth. Whether it's a hydroelectric dam using the force of water, a wind turbine spinning in the breeze, or a nuclear reactor generating steam, they all do the same basic thing. They spin a turbine. That turbine spins a generator, a massive, sophisticated version of Faraday's spinning copper disk, and creates the electricity that flows through our power lines and into our homes. Every time you turn on a light, charge your phone, or watch a video like this one, you are experiencing the direct legacy of Michael Faraday's relentless curiosity in that one spinning disk. His work didn't just lead to generators. It paved the way for electric motors, transformers, and the entire field of electrical engineering. James Clerk Maxwell would later take Faraday's experimental findings and translate them into a set of elegant mathematical equations that form the bedrock of modern physics. Faraday's story is more than just a tale of scientific discovery. It's a powerful lesson in perseverance, curiosity, and the importance of asking fundamental questions. He wasn't driven by fame or fortune. He was driven by a pure, unadulterated love for understanding the world around him. He showed us that the greatest breakthroughs often come from the simplest ideas, pursued with unwavering dedication. So the next time you flick a switch and your room is flooded with light, take a moment to think of Michael Faraday. Think of that humble bookbinder's apprentice in his London laboratory, cranking a small copper disk. Thanks so much for watching. If you enjoyed this journey back in time, please hit that like button, subscribe for more stories from the history of science, and let me know in the comments what other scientific breakthroughs you'd like to explore. See you in the next video.